So you've got your copy of the building code and you're looking for something that's applicable to your structure. You're going through looking for something that looks like your structure so you can get some wind loads out and calculate your structural needs. But there's nothing there. Then you come across at the end a description of a wind tunnel procedure. This is to allow you to get wind loads on any structure. This is how they got the numbers that are already in there. You can do it yourself, but you have to follow the 7 steps that they outline. So we're going to go through those steps right here. Step number 3 is the place to start, oddly enough. It says you need to make your miniature version, which is what you need to have to fit in the wind tunnel. It needs to look identical to the real thing. And not only does it need to look identical, all of the surroundings have to be shrunk down to match as well. If you're on top of the hill, you have to put the hill in. If you're next to another big building, you have to put the big building in. If you're looking at wind loads on solar panels on the roof, you have to put the building in. That's the surroundings. It's okay, so you've shrunk the thing down. But how much do you shrink it down? That's what item 4 talks about. So let's take a cross section of a wind tunnel. It's typically about 10-12 feet across for the kind of wind tunnel you're going to need. If you shrink it down just enough to fit in there, the air's not going to have any way to go around it. You're going to get the wrong answer out. So that's called blockage. You want to avoid it. So they have a requirement. Make sure that the blockage is less than 8%. All right. Now you've got your building or your structure. It's down to about the size of a shoebox. That's typically where you end up. You may have some feature on there that you're really interested in. You really want to know the loads on a sunshade or something like that. Item 6 has something to say about that. Now, item 6 says that you got to test fast enough, the sort of a minimum wind speed. You're typically going to look at something like around 30 miles per hour. You don't need to go faster than that because no new information comes out. So you're testing at that speed. Your little feature has to be bigger than about 1/8 of an inch if you're going to get the information out. So you've shrunk it down. You've got your shoebox. You're ready to go. The next step is to make sure the wind is right. So let's just say that you decided to test at 1 to 300. All this math told you that that's the right size. That's the right scaling. It's 300 times smaller. You need to make the wind 300 times smaller, which is a kind of an unusual concept. But there are 2 particular aspects of the wind that this applies to. One is the rate at which the wind speed increases as you get up above the surface of the earth. You want that to happen 300 times faster. The next one has to do with the gustiness of the wind. So none of these tests can be done in a smooth flow wind tunnel where you might test an airplane or something. You want to have it in a boundary layer wind tunnel where you've got swirling winds gusting around. The gusts just like you feel when you go outside. And you want those gusts to be scaled to match the building. So they're going to happen 300 times faster and they're going to be 300 times smaller than the real gusts that you feel when you go outside. So that's item 2. All right, so we've covered everything but 5 and 7. You've taken your model, you've made a replica of it, the replica of all the relevant surroundings. You've put it in the right kind of wind, a wind that's just like the real deal. Now you have to take your measurements, and you want to make sure that you're taking the right kind of measurements. And that's what items 5 and 7 talk about. Make sure that your instrumentation is adequate for the task. Well, of course it has to be adequate. This is a vast topic. We're not going to get into all the details here. I will just mention that there's a really good chance that what you're interested in is the peak. Measuring average wind forces, average wind speeds is probably not adequate. You want to measure the worst thing that's going to happen. So you're going to have to measure the changing, the varying wind loads and wind forces. Now, so this is a necessary but not sufficient list. You want to match all of these things, and there may be some other things you're interested in, but this is a good start for looking at a wind tunnel test and ensuring that it's adequate.